I'm not even going to try to pronounce the name, but it's a pocket oscilloscope with function generator. I got this one from Banggood. We're going to open it up, check it out, see what you get with the package, see what it can do, and tear it down and see how well this thing's built. This one could be an interesting one. It's actually a lot better than I thought it would be. Today we're going to look at this, how do you spell this? How do you pronounce this name? Mini pocket handheld oscilloscope anyway. FNIRSI. I guess that's what the name of it is. Anyway, it's a mini pocket scope. Comes with, it's got an oscilloscope probe. Well, that right there is probably worth more than the oscilloscope. Save me having to spend $50 and buy a new probe. Alright, so I get a probe. So it's a 100 megahertz scope probe. That's good enough. I think that's probably better than what I've got on my scope right now. I think the one I've got on my scope now is it might be a 100. It's either a 60 or a 100, but it's always good to have a second scope probe that actually has a clip that works, because that seems to be what I break. I had a good one, and I was working on a stupid Sony HF750, the one with the drawer that slides out. And I was checking it, and I just happened to bump the drawer that was sticking out, and I tapped the button, and the drawer went in, and it guillotined my new probe that I had. So I had to go buy another one for like $60. I was not too happy. So this will be a welcome addition to have another probe, where I won't have to use an alligator clip and clip it onto the tip to hook it up to something. Anyway, that's beside the point. Enough of me rambling about the free scope probe that I got with this mini oscilloscope. We're going to crack this thing open. As you can see, it's still factory sealed, and we're going to take a look at it and see what it does and how it works. And I know that these little mini scopes are all the rage now. This is a, what is it? It's a digital scope, of course. What are the specs on this? Does it say? It runs on 5 volts at 1 amp from a USB power source, of course. Kind of a neat little device. And it has the input connector here, and that's what that adapter is for, to adapt it over to a BNC. Little jog wheel here, or I should say selector switch with a push in. And probably a calibration probe, I would think. I haven't even looked at the manual for this thing yet. It runs off batteries too, which is kind of cool. Oh look, let's set it up here. I guess I select it here. English. There we go. Oh, oscilloscope, signal generator, and settings. So it's got a digital signal generator in it as well. That is very cool. The adapter cable here that comes with the package comes with this BNC adapter cable to, I think it's an SMA. But that would just plug in like that, somehow, just like that, and then you connect your scope probe to there, or you connect to this one for the signal generator, which we will also test. Let's connect the scope probe. I haven't even looked at the instruction book yet, but let's connect the scope probe up, and we will see how this thing works. So if I connect my probe, I guess it's probably better to connect your probe to that first before plugging it in, otherwise it's just going to spin around. Okay, scope probe. There we go. Alright, there's the oscilloscope. I'm sure if I connect it onto this is probably the internal generator. I'm going to guess that that's the internal generator, and it is. Weighting measurements. Okay, hit the auto button. Okay, there we go. So, as we can see, it is measuring the test signal, which is 1 kilohertz. It's a 50-50 duty cycle. 172 millivolts is the V max. 344 millivolts total. The width is 500 microseconds. And it's got all these settings: duty cycle, 50-50. Mode, awaits trigger, run. Okay, run and stop. So you can freeze a waveform. Mode, single. You can do single capture or normal. Auto switches back to auto detect. That's actually not too bad. I wonder how it compares to my Uni-T. Let's just shut it off here for a minute and we'll look at the specifications, and then we're going to give this thing some signals to measure. There, just press the button. We'll give this some signals to measure, and we will test the signal generator on here as well. I'll look at that on my other scope. But here's our specification. Well, I don't know if can someone read this? Let's take a look at the specifications in English. So it features a 2.8-inch screen. There's a reset hole on the side, charging indicator and Type-C charging. You get your digital scope input and your digital signal generator output. Square wave calibration, the wheel button, left, right, and OK, auto button, mode button, up button, down button, run button, and power button. I think we can figure that out. So it says the function button. Short press left to select up. Short press right to select down. Short press down, which is this one here. We're talking this wheel. That way is a short press down, or long press down. So short press down enters the menu, and long press returns to the main menu. This is for changing your settings. And over on the other side, short press for auto measurement. Mode button, short press, auto single normal switch. Long press, rising and falling edge switch. And then short press of the up and down. We're talking the mode button here in these ones. Just to adjust parameters. Run, the run button down here, it says pause or run the waveform, and the signal generator, turn it on and off. And long press, display, disable parameter measurement. So that's if we're in oscilloscope. Short press to go to there. If I press this is start and stop it, but if I press it long press it will turn off that display. That's what that means. So you can have the overlay on or off for your measurements. Measurements are always kind of nice. I like this because if you're using this for, say, checking the speed calibration of a cassette deck and you know you've got a 3 kilohertz tape, it will tell you the frequency right there. I like that feature. This actually is a nice looking little scope. I'd be just my first impressions of this from picking it up. This is really nice little unit. And there's the reset hole and the recharge. But yeah, my first impression is, wow. Now my impression might change when I try to measure some signals. We'll measure some audio signals. I'll even try to measure a video signal. I don't know what I expect for that. Obviously, you're not going to be measuring the horizontal output transistor on an old CRT TV with this, because it has 800 volts peak to peak, and you need much higher than that for measuring the horizontal output transistor, which is typically around a kilovolt or so. But for other stuff, for lower voltage stuff, this should be just fine. But we'll find out when I give it some more complex signals. I want to see how they respond to some more complex signals. The vertical sensitivity is 10 millivolts to 10 volts per division. The voltage range is on the ×1 probe up to 40 volts, I should say, and ×10 is 400 volts with 800 volts peak to peak. And coupling is AC or DC. And the signal generator will generate between 0 and 10 kilohertz. And you can generate rectangular and sawtooth waves with an amplitude of 0.1 to 3.3. Here's the waveforms: sine wave, rectangular wave, sawtooth wave, half wave, full wave, step wave, anti-step wave, noise wave, exponential wave rise, exponential drop, DC signal, multi-tone, sync pulse, and Lorentz wave. So let's this cable is obviously for the signal generator. It's got the special SMA type connector on here. I think it's an SMA, or a type of an SMA. Plug that in. That's for the signal generator. So we can take a look at what the waveform looks like first of all, and we can even hook it up to the amplifier. But first, let's measure some audio. So I'm going to clip this onto the audio output from my MP3 player, and we will look at some audio. Okay, I've clipped it onto the audio output from my MP3 player. I'll press the auto button. And indeed, there it is, showing the audio signal coming from my MP3 player. And I can, of course, freeze it. If I press and hold the run key, now I can look at the entire display. And I can, I think, dial down the time, or dial it up or dial it down. So now I can look at a slower sample rate. Now we're at 10 milliseconds. Switch my measurement to 10 times probe. That was where this probe has got a switch here, but you also have to switch the input here. And then if I go over here, now I can select the voltage range. That's 100 millivolts now per division, 200 millivolts, 500 millivolts per division, 1 volt per division. You see, if this was on a times 1 probe, then that would be 100 millivolts, and I'd switch this over to times 1. Right? When times 10 probe, you switch this to the times 10 setting, and then that becomes a 1 volt range. That's how that works. Most people would leave their probe in the times 10 just because it's only got 40 volts rating in times 1. So if you were to accidentally connect it to something that was a little higher power than that, you could damage the unit. I mean, I usually leave my scope in times 10. Sometimes I'll switch it to times 1. Now here's something I found kind of unique. I connected up I connected the digital signal generator, even though I haven't gone into the digital signal generator. I notice that it's on, and I guess that's what that indicates. It's already on, and it's generating a tone. If I go into long press and get into signal generator, you'll see that it's set for 1 kilohertz, and now I can change it to a square wave, a sawtooth, a half wave, a full wave, a step wave. You can hear the sound changing on the audio, I'm sure. Reverse step wave, or a noise wave. Index up, index down. These are the signals, or DC output. Don't want that going there. Multi-audio, a sync pulse, Lorentz wave. I guess those are the different outputs. The signal. This one here is the sync pulse. That's the output levels changing. This maximum output there is 3.3 volts. Two kilohertz, 3 kilohertz, 4 kilohertz. Let's take it down to 400 hertz. You can actually hear the waveform a little better at 400 or 300 hertz. That's 400 hertz there. 440. So there's our Lorentz wave. Sync pulse. Multi-audio. Direct current, we don't want that. Here's our, this one's a index decrease. I have to adjust my trigger level here to lock into that one. That looks pretty good. And again, will my duty cycle do anything on this? I don't know if it makes any change. That may only apply to the square wave. I think that the duty cycle only applies to square wave. Index up, so there's index down, index up. This is a noise wave. Stepped, or reverse stepped, so it's starting high and working our way down. This is the forward step wave. Full wave. Half wave. Sawtooth wave. Square wave. Now this is probably where the duty cycle will change. So 10%, 20, 30, 40, 50, 60, 70, 80, 90%. And you can go in individual percents. I can go 91, 92, right? So that's kind of cool. You can generate a pulse width from 1% to 99%. Just like that. We're down to 1%. 0, obviously there's nothing. So we can go all the way through. That's kind of cool. Okay, so that works. And I'm just selecting this by, obviously, just pushing the mode button on top and selecting it. So that's sine wave. So there's our different waveforms. Right? Sine wave, square wave at 62%, sawtooth, half wave, full wave, step wave, reverse step, noise, index up, index down, DC output, multi-audio, sync pulse, Lorentz wave. Back to our sine wave. Frequency wise, go up to 1440, 2440. I'm just going 1 kilohertz at a time. I'm going to make this right on the even kilohertz. That's 10 kilohertz, by the way, for those of you that can still hear it. And it cuts out. Where does it cut out? Let's see where it stops. Watch your ears. I'm going up in frequency now. We'll see. Okay, it's starting to, at 17 kilohertz, we're no longer generating a sine wave. Where does it start to distort? Actually, even at 4 kilohertz, that's not real good. Oh, you know what? I had the voltage turned up beyond the maximum. Let's set it for 3 volts. That might explain why the signal was distorted. I had it turned up beyond its maximum. Let's go back to frequency now. One kilohertz. 13 kilohertz, 14, 15, 16, 17, 18. Can you guys still hear this? 19. I think it topped out there at 18 kilohertz. So 18 kilohertz, 19 didn't seem to do anything. Oh, there's 20. 21, 22. And it stopped out. It dropped it when I went to 23. It just stopped. So safely you could say 20 kilohertz is what this thing's going to go up to. And then it's going to die. Anyway, waveform looks to be pretty clean. That's 20 kilohertz. Crank that up and listen to the dogs in the neighborhood start to howl. Don't want teenagers hanging around your store? Blast that out into your parking lot. That'll keep them away. 21, 22, and okay, and it didn't seem to change when I went to 22. If it go to 23, it just goes off. That's a 20 hertz square wave there, and it's, as you can see, it's still looking good. 20 kilohertz, not 20 hertz, 20 kilohertz square wave, 20 kilohertz sawtooth, 20 kilohertz half wave, full wave, step wave. Okay, maybe not quite as sharp as it was, but again, we're at 20 kilohertz. It's not too bad, considering this is a low-end device. It seems to be actually doing okay. With multi-audio, sync pulse, Lorentz wave. They all look, even at 20 kilohertz, they all look good. And I don't know if my speakers are putting out anything at 20 kilohertz. But needless to say, if I bring the frequency down, you will hear it, I'm sure. And of course, I was just dialing through the frequencies here, right? You can dial in right down to an individual hertz. So if I go into the one hertz setting, you use it as a sweep generator. Oops, that might be good to my speakers. Hertz. Probably not very good for my speakers at that. My ears. Oh, that's getting very annoying. Oh, the fun of a signal generator. Cool. Some other features that we've got on here, if I press and hold the main button, We've already seen the oscilloscope and the signal generator settings are set up, but how about settings? If I go to settings, we can select the language from all the different languages. Sound and light, this is for adjusting the brightness of the LCD screen. And of course the next one would be, that's the beat when you press buttons. Start up on boot, you can have none, oscilloscope, or signal generator, and you can select your colors, whether you want it to be a yellow display or a blue display. So you can select the color you want the screen to be. And start up on boot, you can have none, where it just goes to the main menu and you select, or you can have it boot up as an oscilloscope or as a signal generator. The signal generator is always on even when you turn it on, so if you leave it at 440 hertz or 400 hertz, whatever, when you turn it on again, that's there, because I'm in oscilloscope mode. That's just for what screen shows up when you turn it on. So none, then you would have to select what you want it to go to. Auto shutdown, you can set it up for off, where it'll continue to run until you turn it off or the battery goes dead. 15 minutes, 30 minutes, or 1 hour. And it just gives you the version of the software and the website where you can go to update the firmware. And it says it now factory reset. So we won't do that. Okay, so that is basically the unit itself in a nutshell. Power off. I wonder what's inside this thing. Should we open it up and void the warranty? Oh, it has a little stand too. Cool. A little stand so it can stand on your desk while you're testing your electronics. That's kind of neat. Because it is held together with a couple of screws, it's just begging to be taken apart. So let's just do that. Will it come apart though, or not? I guess we'll find out. But I did remove the screws, so I'm assuming that the back will probably pop off of this thing somehow. Or is it the front that's going to pop off? Probably the back. It's got a carry strap too, so you can carry it with you. If you want to really look like a geek, you're carrying your little pocket scope with you, like you would a transistor radio. There we go, the back just pops off. Well, sort of. The battery is probably glued to the back of it, which it is. So there's the battery there. It has a 1000 milliamp hour battery, 3.7 volts. And there is the little circuit board that has everything on it. Now there's more screws we could take out and see what's on the front side of it. I don't know if that's necessary or not. It's just going to be unplug that for now. Maybe we can. Let's pop out these screws. They're there, so let's take them out. Remagnetize my screwdriver. This is a nice little screwdriver I got from when I ordered a battery for my Samsung cell phone off of Amazon. It came with this little screwdriver, which is actually a nice little screwdriver. It's the same size as the Sony. It's nice. I mean, it's for free. It fits cell phones, it fits Walkmans, it fits cameras for free. I ain't complaining. Well, it wasn't really free. I had to buy the battery, but the battery only cost me like 25 bucks for my phone. And it's been in there for like about a year, I guess now, and it's still working great. So obviously it was the right battery. I did a video on that. Okay, this just comes out of here. All right, so that's just the case. Didn't really get any further. The screen is still attached. I guess there's more screws to hold the board down. Should I take the screws out and completely void the warranty? Yeah, I think we'll do that. We'll take the screws out here. It might not ever work again, but we want to see what's on the other side of this circuit board. Yeah, there it is. there's nothing on the other side of that circuit board other than a couple of pads to support it and the buttons, and of course the LCD screen. That's all there is there. So we didn't really need to take that part out, but we did anyway. So let's put it back together, and hopefully I didn't get too much. Now buttons are falling out. Oh, wonderful. That's what I didn't want to happen. Hopefully not too much dust got in there. That's why I wasn't putting it on the bench. I was sitting it in this. I know that there's a fair bit of dust on the bench, so I didn't want to get any dust in between the screen and the, although I probably did, but oh well. And as promised, I am going to try to display a video signal on here, even though I know it's not going to display anything. I just want to see how bad it looks. I mean, my Uni-T won't display video, so I don't think this thing's going to do anything. I just want to do it for fun. And I've got a DVD player sitting here that I can just plug in and we'll see what it looks like. Although, this might not even go back together. I may have broken it. I don't know what's going to happen when I reconnect the battery, because I may have lost some settings or something, right? I don't know. I don't know what to expect when this thing goes back together. It should work. Yeah, I'm sure it'll work. If I can remember how the case goes back together. Okay. Some screws to hold the front cover on. Construction-wise, it looks to be pretty good, too. I mean, look at the board. I mean, that board looks nice. I don't see any issues with that. I'm assuming the plug only goes in one way. There we go. It is booting up. And then the back cover goes on like this. Good as new. Now with no warranty. Okay, as promised, I'm going to first of all make sure I didn't break it, but I'm going to hook up to a complex waveform that I know is going to fail, but I just want to see how bad it is. So that's what I say, when you boot it up in the no boot up mode, it goes, see the signal generator came on as soon as I turned it on, but you can set it so that it either boots as the oscilloscope or into the signal generator, right, as far as the display goes. Right, you can have it boot up in that mode, or you have it boot up in oscilloscope, or you can have it just boot up in the menu mode, which is what I've set it to. And then you have to select oscilloscope. But there's the signal generator generating the tone. It is detecting on here. If I click auto, it'll do the auto measurements, and then again, if I press and hold the run, it will display our parameters on here. Set for 440. And the counter out here says 441.8. Let's just see what my other one says. 441.23. So it looks like the counter is accurate. So 441.7, 441.7. Yeah, so it is. The display here is accurate because it's showing the same as my other one. So this is attempting to display a video signal. It's not going to do it. It's going to just... Well, it's kind of displaying the sync. It's not displaying anything other. I mean, there's nothing on here anyway. There's no video playing. It's just the menu that shows up where it says loading disk, but there's no disk in it. But yeah, you're not displaying video on this. I mean, my other one's useless too. If I put the scope probe onto my other one, it's totally useless as well as for displaying video. As you can see, even this one is just a joke. It does not like displaying video. But if I put that onto my analog scope, it'll show just fine. It'll show exactly what. That's why I use an analog scope when I'm setting up CD players and VCRs. I don't try with the digital scope just because it does not like complex waveforms. At least mine doesn't. There's how it shows on a CRT. And that's why I use an analog scope for when I'm working on video and CD players and stuff, just because, well, I can actually see what it does. And if I take that same scope probe and just move it down to this one, that's the mess you get. Anyway, for looking at audio signals and generating some test signals, I think this thing's excellent. For a pocket-sized scope that you can take with you anywhere in the field for doing quick measurements of non-critical stuff, in other words, you're not looking at complex waveforms, you're looking at basic waveforms up to the limitations of the frequency that it can capture, I think this is actually not a bad little unit. And the signal generator portion of this is excellent. You can make your own calibration test tapes, for example, for setting up speed, etc. You've got a signal generator in your pocket. It's a great unit, I think, in that respect. And for what it costs, I don't think you're going to beat this one. Link, I'll put it in the description. Got it from Banggood. We'll catch you in the next one. Bye.